of a set is the number of elements it has. So let's see the set of the size of a set A is denoted with a 2 bar, then put the A in it. Remember in the past we used this 2 bar to represent the absolute value. But in this course, we use this 2 bar to measure the length, to measure the number of elements A has. So let's see. So A is the set of 3, 5, 8, 9, 11. Then the size of A is 5. So just a notation, all right? Just a notation. So the size of A is 5. Or if we talk about the natural number, the size of n, the size of z, it's the infinite, right? It's not definite, it's infinite. And a very special set is an empty set. It's a very important idea. If you're a math major, this is a very important idea. We need empty set. Just like, we need a zero. It's such an important number in mathematics. So empty set contains nothing, but it is a set itself. It has no elements. So we use this to denote. We draw a circle with slashes through it. So this means empty. There's another notation, empty set. Okay, nothing in it. Nothing in it. Empty set, nothing in it. But it's a very important set. It is a set. So the size of an empty set is 0. However, if you think about a contains, so those two are different ideas. So this empty set itself contains nothing. But this one, you see this set? What's this set? This set contains empty set. All right, so this is a very pure mathematical idea. So this is a set, and this set contains the empty set. So that's why the size of this set is 1. Is 1. Okay, sometimes it could be mind-blowing, because one way you think, okay, empty set contains nothing, so the size is 0. But then every set contains empty set as a subset. So anyway, there's some open problems in mathematics. So just to remember this, okay, if we talk about only the empty set itself, the size is 0. If we talk about a set that contains the empty set. So basically, we're treating the empty set as one element in this set. So the size of it is 1. So we can keep formatting sets from empty set, right? Let's see this set, the set of empty set and the set of empty set. What's the size of this? The size of this would be 2, right? If you keep going, see this one. We have empty set, a set of empty set. Then we have a set of empty set and a set of empty set. So what is the size of this set? That will be 1, 2, 3. So we're treating this one as one element in this set, right? So 1, 2, 3. So the size of this set is 3. Okay, elements in sets don't have to be numbers, right? Just as I said before, our class can be thought as a set, and then we can put each student's name, first name or last name in it to make a set. So you see X, set of X contains A, B, C, D, E. Set of Y contains phi, alpha, beta, phi. Z is a set contains all the symbols. S is a set contains these state names. And A can be a set contains the letter of X, Y, Z. Okay, so set is a group of things. Okay, things can be anything. Okay, note set A above has 3 elements. Each element is a set. Okay, so A set A above has 3 elements because we defined x, y, z. Since we defined x, y, z, x is a set.
Professor, when you put your headphones in, I can't hear you anymore.
Oops, I'm sorry. Thank you very much. Yeah, just okay. I was talking about set A. Set A, the size of set A is 3, x, y, z. But the set of x is A, B, C, D, E is 5. The set of y is also 5. The set of z is 4. So sometimes this is, so the idea of sets sometimes could be confusing, but make sure we just follow the definition. You see, the size of A is 3, but X is a subset of A. Y is a subset. We're going to talk about subset later. But the size of X is bigger than the size of A. All right, so this is something different, crucial about set. Okay, let's see this term, set builder notation is used to describe more complex sets. A set A in set builder notation is written as this, right? A equals to left wiggly bracket expression, some expression. We will see the rational numbers here. Then with colon, rule. Okay, any rules we want. Then close with right wiggly bracket. So let's see this example. So we use this double line Q to represent rational numbers. Rational numbers means we can write a number as a fraction. Numerator is an integer, denominator is an integer. Rational numbers like 1/2, 3/7. Right? It has to be, so the numerator and denominator have to be integers. So think about the number pi. Pi is an irrational number. Pi divided by 2, it wouldn't be a rational number. Or square root of 2 divided by 3, that's still irrational number. It's not a rational number. All right. So the definition of rational number is an integer divided by another integer. So we would have this expression, right? So rational numbers is a set. What's the expression? Expression we use P divided by Q. Then with colon, now we define P and Q. So P and Q are in integers. And we require Q not to be 0 because Q is a denominator, right? We don't divide by 0 in mathematics. We have 3 apples shared by nobody. It just doesn't make sense. We just don't do that in mathematics. So we require denominator not to be 0. So this is set builder notation. All right. So let's think about, let's go back a little bit. How do we, so this is rational number, right? Rational number. So let's think about it. Think about it. I'll let you think about it. Think about how do we build a real number in this set builder notation. All
right? We would need an expression, we need a colon, you know, we need some explanations or some rules. So I'll skip Cartesian product. I'm going to talk about subset first, right? Because we just finished talking about sets. Now let's think about a subset. Subset is just a part of the set. Suppose A and B are sets. If every element of A is also an element of B, then we say A is a subset of B. And we write in this notation, A is a subset of B. So with this equal sign, that means A can be B. Remember in mathematics, we say 3 is less than or equal to 5, right? 3 is less than or equal to 5. It could be true because 3 is less than 5. Or we could think of 5 is less than or equal to 5. It's also true because 5 equals to 5. So it's the same idea here. Without this line, that means A an element, whether an element is in the set, right? Remember, let's see we have, remember the 3, remember this set, right? So 3 is an element of A, so we use this notation. We use this notation. But when we talk about set, subset.
Professor,
Yes.
there's like a lot of rustling going on, and it's making it hard to hear.
Oh, I'm so sorry.
I can
now
hear you,
better?
but it's like there's something else in your background that's making it hard to hear.
It's doing renovation probably. The noise.
Okay.
Yeah, I was trying to use my let me try again to use my
It's like something scraping across the desk or paper rustling or something. I don't know what it is.
oh that might be my finger. If that's the case, that's okay. I think let's see if this is better. Oops. Okay, so yeah, let me know the changes. Hopefully now it's better. So basically we're comparing two notations. We're comparing in or belong to for an element in a set and a subset notation. So comparing those notations. All right. Element in a set, we use this. Not in a set, we use this. A set is a subset, we use this notation. A set is not a subset of another set, we use this notation. So do not get confused with these two sets of notations. So let's see now, we have A, set A has 3 elements, X, Y, Z. And the set B has 2 elements, X, Y. Then obviously we see B is a subset of A. So we would write B is a subset of A. All right, but we cannot write B belongs to A. No, B does not belong to A because this is for an element. All right. And we see X is an element of A, so we use this notation. X is in A or X belongs to A. all right? And we cannot use X is a subset of A. No, X is not a subset of A. However, if we put a wiggly bracket around X, will make X a set, then that would be true. That would be true. Let me see. Okay, I need to figure out how to write on this. I cannot write on this. Let me see. No, I cannot write on this. If it's yeah, if it's room, would ask, it would allow me to write on it. This does not allow me to write on it. Okay, anyway. So if we put if we want to fix this mistake, right? How do we fix this mistake? We can put a wiggly bracket around X. So we'll make this X a set. Then that would be a subset of A. All right, same thing for Y. Y is an element of B, but a Y itself is not a subset of B. If we want to make this true, we put a wiggly bracket around Y to make Y a set. Then that would be true. Okay, so intervals are subsets of the real number line, right? That's true. Any intervals is a subset of the real number line. The set of all real numbers greater than 2 but less than or equal to 5. Let's see, we can put this way. This is the interval, right? Right? This interval not including 2, but any number a little bit bigger than 2 is in this set. And up to 5, right? 5 is included in this set. It's an interval notation. Right? So this will be a subset of the real number line. The empty set is a subset of any set. Okay, this is an important concept. This is an important concept. So later on, we will calculate, a set, how many subsets a set has. So we would need to remember to count the empty set as one subset. And every set is a subset of itself. Let's do a little bit practice. Then we talk about the Cartesian product. All right. Let's talk about set and subset. Let me stop sharing this. Let me use a whiteboard. Let's see, we have this set. You think about it. Let's have a set. Use a set A. Remember, set A equals to wiggly bracket 3, 5, 9. Let's see, 7, 9, 11. You know what? In order to save time, let me just make 2 elements. Let's say A is a set of 2 elements. So 3 and 5. Now let's count its subset. Okay, so subset of A. So first we would consider the empty set. So the first one would be, so we write circle empty set. Okay, we should write a circle. Okay, circle. Then the set itself, right? A itself, so it would be 3 and 5. So the second subset. So the empty set is a subset of A, and the set of A is a subset of A. All right, let's see the rest. And 3, the set of 3. Then the set of 5. right? So 3 is an element of A. But if we put a wiggly parentheses around 3, so make 3 a set itself. So then same thing for 5. So how many subsets A has? 1, 2, 3, 4. Okay, 4 subsets. So how do we count? So subsets, the number of subsets is 2 raised by the size of A. Okay. So 2 raised by 2. The size of A is 2. So 2 raised by 2 is 4. And later on, maybe we try, maybe on yourself, you can try, you have 3 elements, right? You have 3, 5, maybe make 7, 3 elements. So the subset, we should have 2 raised by 3. You should have A subsets. Or try to convince yourself with that. Okay, any questions? You're right. If you want to think that way, that's fine.
Hi, what does
Yes.
2 raised to the A mean?
2 raised by exponent.
Yeah, why is it being raised by A?
Remember the definition of this. What is this? What's the size of A? So this means the size of A, right? This notation. That means how many elements A has. We see we have 3, 5, we have 2 elements, right? So that's 2 raised by 2. Does that make sense?
Yeah, a little bit.
Why 2 though? Why is 2 the base?
Oh, that's a very good question. Why is 2 the base? I don't want to tell you the answer. Try this yourself. Try now, let's make a B. But that's a very good question. All right. It means you're thinking. Okay, B equals to, let's say 3, 5, 7. Okay. So think of B has 3 elements in it. No, it has nothing to do with 2 elements. This base 2 is something called a binomial, but we're going to learn. I'm not quite sure if we'll learn in this course, but I'm going to talk about later. All right. So for now, think about this. Think about how many subsets we have here. Let's just list. So we have an empty set. Then we have B itself, that's 2, right? Then we have 3. Oops. We have 5. We have 7. We have 3 and 5. We have 3 and 7. We have 5 and 7. So let me write. So empty set. And the B itself, right? Always subset of any set. Empty set and the set itself. Then anything in between, let's see, 3, 5, 7, 3 and 5, 3 and 7, and 5 and 7. Let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8. You see, it's 2. So this is 2. Oops. 2 raised by the size of B. The size of B is 3. Which is 8. Okay, let's keep going. Oh no, I don't want to do this. That's not what I'm sharing. All right, so that's sets about sets and subsets. Now let's go back to something called a Cartesian product. Right, we all know Cartesian plane. So this is from Descartes. Let's see the definition. Now ordered pair. Now ordered pair is a list. Is this? It's not a. It's a notation. All right. An ordered pair is a notation with open parentheses, A, comma, B, close parentheses. Looks like an open interval, right? Of two things, of A and B. And I think we all know this. Remember, we use X, comma, Y to represent a point on the Cartesian plane. So a point on the Cartesian plane has another name. It's called ordered pair. Okay, just a name. Whenever you see an ordered pair, you think about a point. Okay, a point on the plane. So the order matters, right? The order matters. Usually we say A represents the value on x-axis. B represents the value on y-axis, right? It's corresponding to x-axis, y-axis. And then in this case, it's the same thing. Now, ordered pair, the order matters, right? 1, 2 is different from 2, 1. So now ordered pair is not a set of two elements, right? We do not use this wiggly bracket to represent. If we use wiggly bracket, put a, b in it, that would make a set has A and B as elements. Another definition, the Cartesian product of two sets. Okay, so what is a Cartesian product? We used to talk about product of two numbers, right? We know how to multiply two numbers. And the result we call product. So same thing, we can multiply two sets, A and B. And we give a name called Cartesian product. Okay, we multiply two sets, A and B, and the result we call a Cartesian product. Let's see, how do we multiply two sets? So let's say here we have A and B, two sets. So we write as A cross B, all right? A cross B. Right. Later on, you're going to learn some vectors. All right, vectors also use this idea, A cross B. That's talking about matrix. But anyway, so now we're talking about sets. So A is a set with certain number, with certain elements. B is a set with certain elements. So we define A cross B cross Cartesian product. Okay, it's different from multiplication of numbers. It's just wiggly bracket, left wiggly bracket. Remember, this is set notation. So A cross B first is still a set. It's still a set, right? A cross B is still a set. We see this left wiggly bracket and right wiggly bracket. That represents a set. And how are the elements in this set is defined by this, by the set builder. It's saying the first member and the second member. Okay, the first member came from set A, and the second member came from set B. Okay, so A is in A, little b is in big B. So this is a Cartesian product. Let's see an example. Let's say A has a member of, usually I like to say members, elements. When I say member, you understand as element of a set, all right? So A has element of 1, 2, 3. B has element of X and Y. So then the Cartesian product, A cross B, would be 1, X, 1, Y, 2, X, 2, Y, 2, 3, X, 3, Y, right? So Now you may think about the length, the size of A cross B, right? Because A cross B is still a set. What's the size of this? Let's count. 1, 2, 3, 4, 5, 6. How do we get this 6? Because the size of A is 3, the size of B is 2. What's 2 times 3? 6. 6. All right. So the size of A cross B, the Cartesian product, is a set, and the new set, the size is 6. We can also take a Cartesian product of a set with itself. Let's say B cross B. We will get X, 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 Y, Y, X, Y, Y. Right? The size of B cross B would be 2 by 2, which is a 4. And of course, if we do B cross A, we would get different members, right? Different elements. Right? We would switch the position. But the B cross B, of course, is just B cross B. All right. Any questions? Okay, now let's see the classwork. Classwork connections. All right, let's see. We have 14 minutes. Let's see how many. Oh, no, we have time. We have time. Let's see. So, okay, there are 14 students today right now. Oops. So the first question. So totally is we have 1, 2, 3, 1, 2, 3, 6 of them. So write out the following sets as lists. Let's see I, so the first one. N is in Z. Remember Z means integer. And N is even. N is even. Let's use a chat. So if anyone wants to answer questions, you may type in the chat. All right. Then that would be considered as your classwork grades. Okay. So Moises is saying that's that -6, -4, -2, 0, 2, 4, 6, Great. That's it. Okay. Anyone wants to try the second one? The second one.
Why is it that exactly?
Oh, why is that exactly? Okay. Moises, do you want to Moses? How do I pronounce your name right? Do you want to explain? I'm sorry?
Moises.
Moises, do you like to explain to him?
Yeah, but since it's an integer, so it means either negative or positive. So, and it goes infinite, negative infinity to positive infinity. So what I did was I went from the ... stands for the infinity. So I went from negative infinity to 6, -6, -4, -2. So it stays in even numbers.
Why wouldn't it be finite?
I'm not sure. That's what I figured out when I was doing it.
Okay, that's a good question. That's a good question. Let's think of why it wouldn't be finite.
Integer numbers aren't finite themselves, so
Good job. So let me see, who is that?
Nino.
Yes. Right. Let's see here. N is in natural numbers, right? Oh, hold on a second. I'm talking about which one? N is even. I'm talking about the first one. N is in integers. Z. Z represents integers.
Okay, so
I'm sorry.
Z lets me know that it's integers.
Yeah, you see, this is in the set builder notation. So the first one is saying N, the elements in this set belongs to integer, in integers.
Okay.
So we know integer is not infinite set. So N is even, so this set has to be infinite. Okay, great. I like those questions and answers. Any other questions? Let's see the second one. The second one is saying N squared. Then N squared, N is in natural numbers. N squared, N is in natural numbers. So Patrick is saying 1, 4, 9, 16, 25, 36. What's missing, Patrick? Wouldn't that also be infinite? Yes. Does it start from 0? Moises, natural number, which number we start with?
Don't we start with 1?
We start with 1. Natural numbers are counting numbers.
Okay.
Yeah, whole numbers. If it's whole numbers, we start with 0.
And
so the difference between whole number.
It's natural because there's an N there, right? I mean the bold capital N, right? Okay.
Exactly. Yeah, exactly. And usually we don't use whole number. Whole numbers start with 0. The difference between whole number and natural number is only 0. Okay, great, Patrick. Yes, so start from 1, 4, 9, 16, 25, 36, and to represent the infinite many such numbers, such elements. Great job. Anybody has any questions? Okay, let's see the third one. Now, the element in this set is an integer. So this is telling us this set has to be infinite many, right? And then, oh no, it's not true. That's right. It is. That's not true. Okay, because this explanation, the rules here saying the absolute value of x is less than 4. Let's see, Nino. Let's see, couple of answers. -3, -2, -1, 1, 2, 3. Then Maria saying 1, 2, 3. Nino is saying -3, -2, -1, 0, 1, 2, 3. I would agree with Nino. I would agree with Nino. Let's see Patrick's. Patrick's is, oh, Patrick, maybe you have typo. Right. I think Patrick has a typo. Right. Then Maria is missing something, right? Oh, hold on a second. Absolutely right. Maria, you see the absolute value of the member is less than 4. So that means the element itself can be negative, right? Absolute value less than 4. Great. So Nino, I agree with Nino. Moises, do you see what are you missing? Samuel, is this set an infinite set? No, right? It's a finite set. Yeah. Okay, great. Good job, guys. Good job. Good job. Nothing to be sorry for. We're here to learn, all right? Great. Okay, let's see 4. 4, so the element in this set are in integers. then the rule is x squared minus 1 equals to 0. Anyone has answers for this? I'm telling you that only 2. What kind of equation is this? X squared minus 1 equals 0. X squared minus 1 equals to 0. Nino says -1 and 1. Yes, I agree with you. Maria, you see 0? 0 is not a solution, right? Because 0 squared would be 0. 0 minus 1 is -1. -1 wouldn't be 0. Square root 2. Patrick says square root 2. No. Patrick, you're going the second one. You are on the following one. You're ahead of us. We're on 1, 2, 3, 4. We're on 4. X squared minus 1 equals 0. That means x squared equals to 1. We solve this. It's -1 and 1. Great job. Okay. So there are only 2 members. The 2 members here. 2 elements. 2 elements for 4. Okay, let's see 5. So now the element in this set are rational numbers, are fractions, are rational numbers. Rational numbers means we can write a number into one integer divided by another integer, all right? And the second integer cannot be 0. And the rule is x squared minus 2 equals to 0. Patrick is saying no solution. Great. Right before you said it was square root 2 and negative square root 2. But square root 2 is not a rational number. Square root 2 is an irrational number. So the solution, so number 5, the set, what do we call it? If there's no solution, what is the set? If there's no members in the set, we call empty set. Great. Great. That's Mayat. That's empty set. So the solution for 5 is empty set. Good job, guys. Number 6. So the element in this set are real numbers. Now x squared minus 2 equals 0. Okay, yes, Patrick, square root 2, negative square root 2. Great job. Okay, anybody has any questions? All right, so now I'm going to, let's see. Okay, so for B, C, D. For B, C, D, I would like you to try, then you can show it. All right, try on your own, then write your answers in the chat. Okay, I give you probably like 10 minutes to do this, to do B. Then we'll talk about B. All right. And then if any of you have answers, you can type in the chat as Patrick did. But try all of them, right? Try 3 of them. Okay, in the interval notation, right? Remember open parentheses, close parentheses. Okay, looks good. Okay, Aidan, A-I-D-A-N. You said that B1 has no solution. Why? You see the members in B1 are real numbers, right? Real numbers can be negative, can be positive, and the value less than 4. It has solutions, right? And then Nino, again, I agree with Nino. Nino put open parentheses -4, comma 4, close parentheses. And Patrick, you see the difference you made? You made from close parentheses -3. But what about the -3.9? The absolute value is still less than 4. So we would use Nino's notation, open parentheses -4, comma 4, close parentheses. And the second one, I think everybody did right. Oh, Jinqi, watch out your second one. Your second one, you see, -2 is not in the set. So we use open parentheses. We don't use bracket for -2. Okay, B3, from -3 up to infinity, great. I don't like your infinity, you put 2 zeros in it, great. Let's see, C1. C1, yes. C2, yes. C3, no. C4, C4 likes yes. Good job, guys. Okay, okay. I don't think why is that. Anybody has any questions? Oh, okay. What is these integers?
Question for what? C4?
C4, let me see. C4 is integers, right? You see integers, 0 is in the middle. Then 1, -1, 2, -2, 3, -3. You can continue this pattern. 4, -4, 5, -5, right?
0's not in the middle.
Or you can rearrange.
Is it okay to write it like that?
0 is in the middle. Yeah, it can be written in different orders. You know, the members in the set, the orders does not matter. You can rearrange this to write as a bracket, dot, 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 -3, -2, -1, 0, 1, 2, 3, then dot, dot, dot. Or you can pair up like this, right? 0 is out by itself. It's like in the middle. Then you have a pairs. You have 1, -1, 2, -2, 3, -3, 4, -4, so on and so forth. Make sense? Okay. Any other questions? All right, let's see D. D, anybody try? Let's try D. So now I was finding the size of the set. That's 8. Okay, let's see. So now it's a natural number, right? The element in the first set is a natural number. It means 1, 2, 3, 4, 5, so on and so forth. But then the absolute value has to be less than 5, right? How many? 4. 1, 2, 3, 4. Right. So 2. So what is the size of empty set? Oh, Patrick is asking, what about the negative? So this thing X is in natural numbers. Remember, Patrick, natural numbers start with 1. Natural numbers are counting numbers, start with 1. Okay, second one. Anybody has answer for the second one? What's right? The first one size is 4. The second one, good job, size is 0. So the empty set itself, the size is 0. Why is the first one 4? Oh, because we started with 1, 1, 2, 3, 4. Those 4 numbers are less than 5 in natural numbers. Make sense? Right. So the n means natural numbers. Natural numbers start with 1. 1, 2, 3, 4, 5, so on and so forth. Right. If it was z, it would be different. Right. If it was z, that would be 8. The size would be 8. Because we have -4, 4, -3, +3, -2, +2, -1, +1, and 0. It does not go until 5, though. You see, 5 is not, we have less than 5. So the element has to be less than 5. So it only goes to 4. 1, 2, 3, 4. If it's a real number, right? If a real number, the absolute value less than 5, how many we have? We would have -4, 4, -3, 3, -2, 2, -1, 1, and 0 in the middle, right? So we would have 9. The size would be 9. Okay, good job. What about D3? What's the size of D3? 2. All right, great. 2. Even A is a set. Even A is a set. But this set is an element of this set. So the size is still 2. So what about D4? Right, 4. Obvious, right? Right, we have those 4 elements. Okay, great. Okay, now I'm going to give you another, let's see, 10 minutes for 2, A and B. Remember, this is a Cartesian product, right? Make sure you follow the definition of Cartesian product. If A cross B, you get all those ordered pairs. The first member from side A, the second member from set B, you just list all of them. If it's B cross A, the first element from B, the second element from A. All right, so try 2A to B. Iden, make sure you use right notation, okay? Yeah, remember, look at Samisha. Look at Samisha's A cross. Also, Samisha, use the right notation A cross B. Use X. Use X to represent that. A cross B. A cross B. A cross B is a set. Okay, let me write this for everybody because this, I think at the beginning is difficult. So A cross B equals to bracket. Then remember it's ordered pairs. Okay, if you use wrong notation, it just does not make sense because we have to go by convention. AC, so I have AC and AD. Then we use ordered pair. We have BC, BD. Okay, let's say AC, AD, BC, BD. Okay, I'm writing. Oh, great. Right. Look, Samuels. Look, Samuels. A cross B equals to left bracket, wiggly bracket, AC, ordered pair. Oh, AC, AD, right? Samuel has a little typo O. The second ordered pair is A, comma D. Then BC, BD. Then remember close with right wiggly bracket. Right. I wrote under Samuels. All right. A cross B. So make sure it's very important to follow the right notation for when we talk about sets. Okay, Moises, ACAD, BCBD, perfect. B cross A, CACB, DADB, perfect, Moises. Look, Moises, perfect. 近期 missing equal sign, also missing the wiggly bracket, all right? So when we talk about sets, the notations are super, super important, all right? It's different from the normal mathematics. Because I'm guess taking this course, probably you're either math majored, you're going to a route of pure mathematics. Okay, G B cross A, CACB, DADB with the perfect, okay? Right, let's make sure we have the right notation. B cross A, CACB, DADB, perfect, Samisha. Great. All right. So B would be similar, right? B, so A cross B, we would have 6 members. And the B cross A also gets 6 members, but we have different ordered pairs. Let me see if there's anything. Okay, let me now skip B, all right? But you can do B yourself. Okay, someone did B. B cross A, okay, good job, guys. Okay, now let's do 3. 3A and 3B. Okay, anybody has any questions? I don't want to go too fast too. Anybody has any questions? Okay, if not, let's keep going with 3. So 3, we're counting subsets. 3A, 3B. Okay, looks great, but also make sure we use the right notation. Okay, remember how many subsets we should have? We should have 2 raised by 3, right? Because this set has 3 elements. So the size of this set is 3, so 2 raised by 3, we should have an A element, A subsets. Let's see who has A subsets. Let's count Moises. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So Moises has A subsets. Samuel, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Samuel, why you have 9? Let's see. ABC, AB, BC, AC, ABC. Oh, you listed AB twice. That's why. Okay. Maria, empty set. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. You are missing set of BC, Maria. You see that? Set of BC, right? Shamisha, 1, 2, 3, 4, 5, 6, 7, 8. You're also missing which one? ABC, AB, BC. Oh, you're missing AC. Shamisha, you're missing AC, set of AC. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Great. Aya. I'm so sorry. You have to teach me how to pronounce your names. Nino, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Maya, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Great. Okay, good job. All right, let's try to answer 3B. B is yes. Okay, is it true that a set of 1, the set contains only 1 is a subset of the set contains 1 contains a set of 1? Yes. Why or why not? Because it's just a subset, right? Yes. Okay. Okay, good. Let's keep going. If anyone has any questions, feel free to stop. Additional problems. So let's see. Yeah, let's go through this. So the first one, suppose the set A contains 3 elements, square, what do you call this? A triangle, rhombus, right? Is this called rhombus? Rhombus or kite? Anyway, so I have these 3 shapes. So which of the following is correct and incorrect? Use the notation. So A, let's see. A is correct, yes. B, is B correct? No. C is a set contains a square triangle subset of A. C, yes. D is a set of this rhombus subset of not subset element of A. D, is D true or no? D false, right? D is false. Remember, this is element, but this is a set notation. Set, we have to use subset notation. So this is not an element of A, because A does not contain the set of this. It only contains the rhombus, but not the set of rhombus. Sometimes it's confusing. Right, okay, Patrick, when you see the bracket, that's a set, all right? So let's see. Let me type in here. So 3 and 3, set of 3 are totally different. Okay, you see 3? Let's talk about this. Okay, 3 is 3, right? If I have A equals to 3 and a set of 3 . Okay, look at this. So 3 and a set of 3. So when I put a bracket around 3, right, I make a set. This set only contains one element, and the element is 3. So you see A, you say I made one set A. This A contains number 3. It contains the set of 3. Does this make sense? You see the bracket makes a huge difference. So the first 3 here is the element, right? And the second one is a set of 3. Is a set itself. So D is false. Right. It would be right if it did not have the bracket. You're right. You're right. For B, if the diamond has bracket, it would be true. For B, yes. For B, if the diamond has bracket, yes, you're right. Right. Okay. Now let's say E. Is E true? Yes. What about F? Yes. What about G? Good. What about H? H is an empty set, a subset of A? Yes. An empty set is a subset of any set. Empty set is a subset of empty set. Okay, now let's try 2. 2, we have a set A is defined as this. The element of A are in the integers, and x squared equals to 4. And B is a set of letters in English alphabet, vowels. All right, so you could count how many vowels in English. You make that list. What is the set of B cross A? What is the size of B cross A? Okay, great. I'm going to give you 10 minutes to do this. Do 2 first. Let's do 2 first. Because 2, we have to find B cross A. So 2, we have to find a set of A. Set of A, we have 2 members, 2 elements. Set of B, we have 5 elements. And then we have to find out B cross A, Cartesian product. And then we have to count how many elements in B cross A. All right, let's focus on 2 first. If you finish 2 very quickly, you may try 3, all right? And I know for some of you are quicker than the rest of us, so you can keep going.
吴姐妹，晚上8点钟上课是吗？
How do we know how many elements are in B? Okay, good question. How many vowels in English alphabets? Well, we have 26 letters. How many vowels? 5, right? right? Each red is saying 5. Remember A, E, I, O, U? 5 vowels in the alphabets. Lino is saying, okay, the first set of A has a 2 and negative 2, right? So the size of A is 2, and the size of B is 5. So the size of B cross A should be 10. Let's count to see if she has 10. So she has a negative 2 A, negative 2 E, I, O, U, then 2 A, E, I, O, U. Perfect. Perfect. Let's see if this doesn't make sense for anybody. So A, let me write in this. So A has 2 members, negative 2 and 2. And B has, oh, there's only one mistake in Lino. We are doing B cross A. How do we change your answer? Lino, you are doing A cross B, right? So we're doing B cross A. So Lino is almost right. Lino's answer is for A cross B. But the question is to find B cross A. So the size of B cross A is 10. All right, because size of A is 2, size of B is 5. 2 times 5, we should have 10. We should have 10 elements in B cross A. Okay, Maya has B cross A, A minus 2, A2, E minus 2, E2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. A, E, I, O, U with 2 and negative 2. Perfect. So the size of B cross A is 10, right? The size, so we write as this. B cross A equals to A times B. Okay, you see here I use X. Well, the second X I should use the multiplication dot, right? So the first X is a Cartesian product, but the size of A times the size of B this time is multiplication in real numbers. Okay, Maria, yeah, A, E, I, O, U with negative 2 and 2. Great. All right. Okay, now, anybody has questions for this? Okay, if not, let's do 3. So 3, we want to write the following in set builder. Remember set builder? We have expression, colon, and rule, all right? So instead of writing as elements, we want to write as expression, colon, and with rules or explanations. What is, okay, if you see B is an element, right, Maria? That's a good question. What's the absolute value of B? So B is an element. When we put a bar around B, that means absolute value of B, right? Because only when we use a bar for the set, you see the set I have here, that means the size of A, the size of A. So A, the big letter A represents a set. When I put 2 bar around my set, that's finding the size of it. But if we put a 2 bar around the element, that means absolute value of the element. So what is the absolute value of B? It depends on B, right? If B is positive, the absolute value of B would be B. If B is negative, the absolute value of B would be negative B. Make sense, Maria? Okay, let's try 3.
谢谢吴姐妹。
Okay, Maria, let's put this way. If B is just a B, just an element of a set, right? You know, we don't really know. Just B, if it's just a letter, just we take the literal meaning of B, it's just a letter. There's no absolute value of it, right? Then, you know, we put a bar around the element. It doesn't make any sense. But if we want to see B as a variable, right? If B is a variable in that sense, then absolute value of B depends on the value of B. Does that make sense? Okay. All right, let's focus on 3 now. Okay, Patrick, for x in z, x is an integer. Patrick, is this for first one? Right, you see x is not in z, right? Because z has, oh, x in z, x squared, you mean? X is raised by 2? Or x times 2?
X times 2?
Right, think again, think more.
Okay.
Think more. You see the first one, or you want to see x raised by 2? Yeah, keep thinking. You're almost right. But you're almost right. But the x is not in z. Because we don't see negative numbers, right? When we want to use z, basically, you know, we see some negative numbers. Maybe you want to limit this with natural numbers. Yeah, the first one is kind of tricky. I give you a hint. You see, the first 2 is just a 2, right? The second one, what's the second one? So 4
All of them are just
2
double
by
the
n.
previous element, I guess.
Okay, so Nino, just one more step. N in n, great. Yeah. So the first one is 2 raised by 1. The second one is 2 raised by 2. And A is 2 raised by 3. 16, 2 raised by 4. 32, 2 raised by 5. 64, 2 raised by 6. So that's 2 raised by n. And this little n is in natural numbers. Great. Yeah. So we will write in the set notation as this. As n in n, then 2 raised by n. That in the set builder notation. So n in n colon 2 raised by n. Yeah, it wouldn't be the E looking, but in our chat, there's nowhere to do the E looking symbol. But then normally when we write with our hand, we use that symbol. But for now, let's just see, N in N. B 3, 4, 5, 6, 7, 8. X in Z. X is in between 3 and 8. Equals to 3 equals to 8. That's cool. That's cool. And the Nino is in X is in N, natural numbers, and N is in between 2 and 9. Grade 2. Good. You see this second one? We can use different set builder notations. And Shamisha is in X in Z. Yes, Shamisha and Patrick is the same. And Nino is different, but in the sense, it's the same set. Okay, it's the same set. We usually use different builders. Great, good job. But you can use the less than sign and equal sign as Shamisha did. You see, you have arrow on the computer. You have equal sign on the computer also. Or maybe you can use bracket also. You can use the interval notation. But use interval notation, you have to be careful. Interval notation, you could use Linus, right? In N. N has to be in N. Yeah, you could do that. You see, with the Linus one, right? We can write N in N, then 3 to 8. You know what? Forget about it. It's not so good. Let's not use it. Let's only use interval notation for integers. All right, for real numbers actually. For real numbers, let's use interval notation only for real numbers. If the element is in real numbers, let's use interval notation. Okay. For all others, forget about interval notations for now. All right. Let's see. So we're trying C, right? Oh no. N in Z. Right. So C is an interval notation, right? It means from -6 up to 7. Because C is not a set notation. Aja is in N in Z, no, N in R. Okay, interval notation is for real numbers. Okay, so C is confusing, all right? C is the interval notation. So let's see, let me write here. -6 to 7. Okay. So this interval notation is for real numbers. So any numbers in between -6 and 7 includes -6 and 7 is in this set. So Lino is saying a set X in the real numbers, X is in between -6 and 7 with -6 and 7 included. Great. Yeah. So Lino's set is perfect. So D is talking about the domain of the function. But domain of the function, we can use set notation as well. F of X equals to square root of X minus 2. Oh, our D is Y is R. Okay, because the notation is for real numbers. When we talk about interval notations, we talk about on the real number line. All right? We always, real number line, right? 0 sits in the middle, to the right are positive numbers, to the left are negative numbers, and all the real numbers are on this line. So, some numbers are very difficult to represent, like a pi, like an Euler number, like a number phi, number phi. They are irrational numbers. So how do we represent? We use interval notation to represent. So you see pi, negative pi is in this interval notation of -6 to 7, right? So how many numbers in between of -6 and 7 is that? So this interval, in this interval -6 up to 7, the infinite many numbers. So this set contains infinite many numbers because this is a subset of a real number line. So for now, only for now, okay, we're using interval notation only for real numbers. Just for now. Okay, let's see D. D, so X in real number, X is greater than 2. All right, can X be 2? Can X equals to 2? Moises? No, why not? Okay, let's think about it. What's right? The inside cannot be, so X minus 2 greater than or equal to 0, right? The domain of this function. So inside the square root sign cannot be negative. Cannot be negative means can be positive or can be 0. So X equals 2 also included in this set. So I would just change Moises' set a little bit. I just put an equal sign there too. X greater than or equal to 2. Yeah, like a Shemisha's. X is a real number. So the element in this set are real numbers, and x has to be at least 2. Okay, good job, guys. Wonderful. All right, anybody has any questions or anything is confusing today? Let's just go back a little bit to review a little bit. Let me share with you. So let's see, what have we learned today? Homework, I give you 1 week to do every homework, all right? You better to do today. Oh no, did I give you 1 week? Not 1 week, I'm sorry. Every homework is due next class. 1 day, 1 day. Lecture notes. Let's go back to lecture notes to see what have we learned today. Okay, I would encourage you to preview the lecture notes. Okay, just go ahead of the each class. So get a little bit idea. Of course, when you read the lecture notes, probably something that doesn't make sense. Do tomorrow, yes. So preview the lecture notes, you know, when you have questions, ask in class. Okay, let's do a little bit review to see what we have learned today. So basically, we learned the sets, the notation of sets, the definition, right, and the subsets. And then with Cartesian product, we can multiply 2 sets, all right, which is called a Cartesian product. Right, a set can be a group of anything. We just use this wiggly bracket. So whenever you're talking about set, remember to use this wiggly bracket. And we have a finite set. We have an infinite set. What's the assignment? Assignment is on the blackboard too. All right. The homework 1. Homework 1 is assignment. You're probably late today. Okay. So it's this. You have 10 homework. All right. So today's the first lecture. You have 10 lectures. We have 10 lectures. We have midterm. We have final. And each lecture followed by classwork, by homework. All right. Classwork we would do in class. Homework you have to finish. You submit through CUNY Blackboard. All right. So each homework, let me just share with you. Let's close. You know what? Let's finish. Let's finish reviewing this. Then I'll share with you. So we learned the sets and the subsets and the Cartesian product, right? So we can make anything inside a bracket, wiggly bracket, and call it a set. We have a finite set. That means we have finite many. We have infinite set. That means we have infinite many element. And for element in the set, we use this notation. It looks like a E. And also we can talk about subset. Subset, we use another notation. Subset, we use this notation, all right? Subset. Natural numbers are counting numbers from 1, 1, 2, 3, 4, increasing by 1. Integers from negative up to positive, right? And real numbers is difficult to represent this way, so we use a number line, all right? Basically, we draw a line with an arrow to the right. And for a set, if it's a finite set, we can always tell the size of the finite set. So we put a vertical bar around the set, indicate the size of the set. That means how many elements we have in the set. And a very important idea is empty set. Empty set is in every set. And we have this set builder notation. Okay, we have expression, the colon followed by rules. Cartesian product we represent with ordered pairs, right? If we have A cross B, so ordered pairs, the first element comes from the first set, the second element comes from the second set, Cartesian product. And That's it. That's it. What we have learned today. Any questions? Okay, if not, let me share with you how to find homework.
Professor,
Yes.
sorry about the homework again, but I'm confused because they all have a due date of January 24th.
Oh, that's just for my convenience,
So
right?
you
For
want each day's homework done by that night.
right, by next day, before we meet. I think better to learn that way, right? Because this is a winter course. We only have 1 month. If you leave everything to the last day, this just doesn't make sense. What do you think?
Okay. So today's homework is due by 1 p.m. tomorrow?
Yeah. You know how to submit,
Okay,
right?
thank
You're welcome. You see
Yeah, I
from
know
here,
how to submit. I was just confused because they all say the same due date.
I know, right, I know. Okay, you see the homework right here, then the 10 homework in total, all right? So just try to finish tonight, I mean before 1 o'clock tomorrow.
How do
And
we submit it to Professor?
let me see, from your side, assignment. You see here, do you see resubmission?
I see it on your screen.
Right, you should have it too. They should give you submission button. You don't see it? Okay, Moises is saying click on homework number.
Okay, I got it. Thank you.
Okay, great. Great. Okay, anybody has any other questions?
Yes, I did. On the lecture notes, when we were going over one of the problems, I was still a little bit confused.
Which one? Let me pull it up. So let me share with you. Okay, which question? Hello? Which number you were talking about?
Number 2.
Number 2. Number 2. Okay, the set A will have 2 members, right? 2 and -2, right?
Yes.
Set B will have 5 members, A, E, I, O, U.
Yes.
Then what is the set of B cross A? Remember we use ordered pairs? Let me see
Yes.
if I can type in the chat.
I remember that. I just had problem with the absolute value of B times A.
Oh, okay. That's not the absolute value of it. That's the size of B
size.
cross A. You see B cross A is a set, right?
Okay.
A set with all those ordered pairs.
Okay.
So the size of A is 2. Size of B is 5. So how many ordered pairs we can make?
10.
We would make 10. So that means the size of B cross A is 10.
Okay, thank you.
You're welcome. Okay, anybody has any other questions? Okay, I think you guys have done marvelous jobs today. However, let me see. I would hope to hear from George more next time. George, are you here? And Xiaoming, are you here? Yeah, I would hope to listen to you guys more, okay? The rest of you, I think you are being very good on participation on classwork. All right, so I would hope to listen to George more and to Xiaomi more, so you can get, because 20% of your grades come from this, come from class attendance. That means you are here. I see your name on the list. Also, that means you are participation, right? So 5% for each class, 5% for attendance, and 5% for participation. Okay. I don't care if your answer is right, right or wrong, or if you get the right answer, awesome, right? Great. And if your answer is wrong, let's learn together. This is a class of learning. All right. Don't feel embarrassed or something. Okay. It's a process of learning to make mistakes. All right. Okay, great. Maria is trying to create a group chat. Yes, right. Connect with each other and yeah. Let's see. What is the midterm next Tuesday? The midterm is a 6 week. It's a number 6 week. Okay, midterm. No, not so fast, right? Let me see. So it's not 6 weeks, 6 lessons. So 1, 2, 3, 4. You're right. You're right. It's 12. It's on 12th. You're right. The 6th day when we meet. It's on 12th. You're right. Midterm is on 12th. So this class is very, intense, right? So let's keep it up. So, hopefully all you guys get the material, understand what's going on. And so we finish very well in this month. All right. Okay, George posted his number here, right? So hopefully you can study together. And I see you tomorrow. All right.
I have a question.
Yes, go ahead.
For the extra time for accessibility.
You mean when take exam, you need extra time?
Yeah.
Yes, that means you need to contact accessibility. So I will let them know what's going on, how to practice you, and they will do that for you.
Okay. All right. Thank you.
You're welcome. Okay. Any other questions? Okay. Thank you, guys. You guys did a wonderful job, and see you tomorrow. Okay.